Stefano at ARW Misure. In this video, we're going to take a detailed look at a brand new product. Specifically, we'll be discussing the features of the ARW-196 Gaussmeter. As we can see, the instrument comes in a case, a very sturdy and protective carrying case, where inside we find the main internal unit of the system. Then we will carefully examine each of its various operational functions and a specialized zero chamber, a zero Gauss chamber, which is a unique feature not typically found in many other instruments and is a vital zeroing component. The transverse probe, which is the standard probe included. This device is commonly referred to as a transverse probe because it allows you to directly measure the strength of the magnetic field transversely, with the sensor positioned at the very tip of the probe's end. Finally, we have the internal batteries that power the device for the entire instrument to function correctly. Now we will take a closer look at the functions, specifically the internal menu, the various functions that the instrument has. This is a Gaussmeter. So it is an instrument that allows you to measure and detect the static magnetic field of a permanent magnet, or in alternating fields, a sinusoidal waveform generated by an electric motor. For example, let's take a look at and analyze the main features of the Gaussmeter, the magnetic field rotor, the ARW-196. We will look at the keypad, we will look at the functions, and therefore also the menu, what we can do and determine with this instrument. The instrument is equipped, as we mentioned, with a transverse probe that basically allows you to detect with the sensor located at the very end, at the tip of the probe. And then we will furthermore explore the potential opportunity of successfully conducting a detailed measurement on a triaxial level. The instrument is equipped with a large display, a very large display that allows us to always keep everything under control. There is also a keypad that allows us to control any function directly from a dedicated function key. Here is the power button. Before you proceed to turn on the power to the instrument, it must always be switched on with the probe already connected, so the connector must be installed directly onto the instrument itself. Otherwise, the system will automatically display an error message on the screen and shut down immediately. Once we have successfully turned on the instrument, we will be able to immediately see the indication of the current magnetic field strength. In this case, we have Gauss. Now we will go through all the functions and also how to change the unit of measurement. We have selected DC, so direct current. We are in auto range and not manual. We also have the option to change this. Additionally, the device directly shows us the specific memory position for each measurement. We have the capacity to store about 90 individual readings in the internal storage, which can be reviewed directly on the instrument itself. It is important to note that there is no external data connection available, and there is no software included to manage the saved memory. Here we have the battery symbol, which lets us know when the battery is low. Let's take a look at the various functions. So, we have the ranger function, which allows us to set a range, either automatic or manual. Either automatic or manual control. Clearly, this significantly changes the resolution of the instrument. It is highly recommended that you always leave the device set to the auto range mode for optimal performance. We also have the dedicated unit button, which conveniently allows us to manually select between several different measurement scales. In this particular case, we can choose from kilo per kilo, ampere per meter, millitesla, and Gauss, which represent the three most commonly used scales for these types of magnetic readings. The Gauss scale, which is a commonly used standard scale in addition to millitesla and Tesla. Here we have the zero button. Here's something interesting. The instrument is equipped with a camera. This is zero Gauss. We will see later that this allows us to zero the probe before taking measurements, which is extremely important and useful. A feature that many instruments, for example, do not offer as a standard feature or provide separately at an additional cost. Here we have the REL function, which is basically the ability to set, as we will see later on in the menu, either automatically or manually, an offset value. This means a value that gets subtracted from the total. For instance, I can set a magnetic field that I want to be subtracted from my measurement. For example, it could be a background magnetic field to ignore. Here we have the illumination grid. We can turn the illumination grid on or off. Here we have 2 buttons, actually 4 buttons, that each have 2 functions. So here we have the upward arrow function button, which of course allows us to move through the menu or increase the numerical value, but we also have the specific selection for AC, used for the alternating magnetic field functionality. Simply by pressing the down arrow, we select the DC field measurement, or while in the configuration setting mode, we can decrease the value accordingly. The right and left directional arrow keys also serve to perform a dual function. Here as well, M is used to save the value. In fact, if I press it, I see that the value has increased. While you are still in the settings mode, you have the convenient option to move directly on the display by using the directional arrows. The R button, on the other hand, specifically allows us to read the current values. In fact, if we use the arrows, we can easily view each of the 6 different values that have been saved in the memory. It is all very simple. If we just press it once again, we will exit the menu and return to the main screen. The internal memory function is primarily designed for storing your recorded data points using the M button, and for directly reading that information on the instrument's display with the same M button. Below that, we have the Hold button, which gives us the ability to instantly freeze the current reading. By pressing it once again, we can release and unlock the measurement. Finally, the Max-Min button allows us to access the full statistics function. Let's call it data, or recording of values, maximum, minimum, and average. In fact, if we press this button, we see that we enter the maximum mode. If we take a measurement of a magnetic field, it will always only display the specific numerical value, well, maximum. And Ivano, when we press the button once more, we see the current minimum value, which in this case is 0, and the mean average value. Which is a value averaged over 16 times. This measurement is taken across 16 different samples. When calculated per second, I believe that is the specific value we are looking for. Now, in order to exit this configuration setting, you simply need to hold down the main button for a few moments until you see the icon at the top of the screen completely disappear. This function is interesting, for example, to check the peak levels, so you can record the maximum level and the minimum level. In this section, i.e. the very final function we need to cover, which is the last button present, is the alarm button. By simply pressing this button, we can easily activate or deactivate the alarm function, switching between alarm on and alarm off. Now let's go and look at the various settings in the setup. To access the device settings menu, you will find a button located in the center. It is necessary to press and hold down this central button to successfully enter the configuration setup mode. The very first configuration option is the audible beep notification setting. In this case, by using the directional up and down arrow keys, we can enable the sound or disable it by selecting off. Or disable it, basically on or off. Press again and we move on to auto power off. Here too we have the option to set an auto power off. In this case, auto power off is off, which means the device never turns off by itself. It only turns off if I press the button. If we interact with these physical buttons, we can see the increments of 5 minutes, 10, 20, 30, 60, and even 90 minutes. That is to say, I have the specific option to set the device to remain operational and stay on for up to 90 minutes before it automatically turns itself off. If there is no movement detected and no button is pressed on the keyboard at all, the system will shut down. We set it to 0. The next function we will discuss is the QBR function, which serves as a user calibration function. Within this function here, once again, we have the available option to either enable or disable it, but this is only possible if we have samples or specific values on which we can actually perform the calibration process. Next, we will be setting up the relative value, which we can also configure to enable automatically, as we will see later on in this guide. In this section, we can manually set a specific offset value that will be subtracted during the measurement process. That is to say, we can set, for example, 100 Gauss, so that the 100 Gauss of the relative value is subtracted from the measurement I take. In this case, we have the alarm setting always as the next function, always by pressing the central button. Let's move on to the last two options in the settings, which are the high alarm setting, AI, and also the central button. Here we move and use the arrows to navigate to the digit and select the value we want, both for the maximum value, which in this case is set to 2000 Gauss, and for the minimum value, which is set to 100 Gauss. With the button we saw earlier, we can enable or disable the alarm function, which gives us a beep and a signal directly on the display. Once we continue pressing the buttons further and configure the specific alarm threshold values if we are interested, we can exit the menu system directly and return to the standard measurement mode. Now let's take a look at some practical real-world application examples for using the Gaussmeter. In this case, we have a permanent magnet. In fact, we will work in DC, in continuous. We have a solid steel calibration block, and we have the zero Gauss chamber. So this is the standard probe zeroing procedure. All we need to do is carefully insert the probe into the chamber until it reaches the very bottom and manually press the button to zero it out. The instrument will then begin a countdown process, after which, once the entire process is finished, it will automatically reset itself to the starting position. The probe. We are talking about numerical values, very clearly 0. It is quite clear that 0.19. This is a magnet, a permanent magnet. We will see that by carefully placing the measurement probe, we detect a specific numerical value, which is a vector value representing both magnitude and direction. Here we have a solid rectangular steel block. If we were to take and then proceed to magnetize a specific point on this block, we remove it, we will see that we have a magnetic residue at the point where we performed the magnetization. An interesting feature also offered by this instrument is the possibility to take a triaxial measurement, that is, to evaluate the three axes X, Y, and Z, and to perform a vector sum of the three axes. To do this, it is enough to hold down the hold button. The first axis is... First, let's begin by taking the initial measurement for the x-axis. By carefully pressing the mole button, we can confirm this specific measurement in the system, and then we will smoothly move on to calibrate the y-axis. Now we are going to perform this step in a more detailed way that makes the entire system much clearer for you to understand. Once that is complete, let's proceed forward to the final stage by adjusting the z-axis accordingly. Once we have confirmed the z-axis, we have the vector sum of the three axes. This is a function that can be interesting, for example, in certain applications. By holding down the hold button for more than 3 seconds, we return to normal measurement mode. At this point, as far as the explanation of the instrument and its various features and functions is concerned, we've covered everything. For further information, please refer to the end credits shown in this video.